we're going to aim for about 45 minutes plus or minus, and then just some discussion, or maybe like up to an hour. Yeah. Okay, we're just going to give it another couple of minutes, another minute or so, maybe 30 seconds, just to let last few people join. People will continue to join as we start, but yeah, we will get going shortly. Okay, I think we will begin now. Yeah, let me welcome you all to this. The title slide is great. It has times in New York, in London, in Paris, Munich, and Frankfurt, but it doesn't have the time where I am, because I'm coming to you live from Singapore. So it's 10 o'clock at night here. Enjoying my time visiting NTU here, but it gives me great pleasure to stay up till 10 at night, because we have the joy of Mirko Wiederholt, who's going to present. Many of you will know Mirko's work, so I'm not going to give him a long introduction and embarrass him. But you know, he's had this sort of very influential role on things very much related to communication, namely about information. What's sort of super exciting about his most recent work, especially for people like me who find all the really hard theory hard, is that he's now working with, you know, surveys, he's working with expectations. And this particular paper on the effects of monetary policy is joint with Chris Roth and Johannes Wohlfahrt, who many of you will know from their work on sort of experimental macro information provision things. So this is going to be the effects of monetary policy theory with measured expectations. So Mirko, the usual rules are going to be that you have the floor. People in the audience, if you have questions, if you place them in the Q&A, then at opportune moments, I will try and interrupt Mirko and put your questions to him. And then after about 45 minutes to an hour, depending on how many interruptions, we'll stop and we'll have a discussion. And, you know, we usually end either after somewhere between 1 hour and 1 hour and 15, with the 1 hour and 15 treated as a fairly hard end. So put your questions in, and otherwise, Mirko, I hand over to you to if you want to share your screen, and then we will get you going.
Okay, thanks so much. Thanks so much, Michael, for asking me to present this paper. It's a great pleasure. As you said, this is joint work with Chris Roth and Johannes Wohlfahrt. The title of the paper is The Effects of Monetary Policy Theory with Measured Expectations. What we do in the paper is that we propose a new approach to compute policy counterfactuals. And the key idea will be to elicit expectations under alternative policies that are on the table at the central bank, and then feed these expectations that are elicited for alternative policies into a model, and thereby be able to do counterfactuals. So say, what would be outcomes under policy A, under policy B, and so on. So that's the key idea. Let me motivate that a bit more by kind of considering the following situation. Suppose you are a central banker, so you work at a central bank. I see Michael on the screen. And then you have an upcoming policy meeting, and you consider implementing policy A, some alternative, or policy B, the baseline. And think of what we call policy A or policy B, doesn't matter, but just think of policy B as the policy that you go into the meeting thinking that's probably what you're going to implement. and policy A as some alternative that you're considering, but that you might also actually decide to implement. And now you would like to know what is the effect on the economy of implementing this alternative policy instead of the baseline policy. So in the language of theory, you would just like to do a counterfactual. What's going to happen under one policy? What's going to happen under another policy at the exact same point in time in the same country, same circumstances. And then what we do in this paper, we propose a new approach to answer this question. So to come up with a forecast of what would happen under policy A instead of policy B. And the idea is very simple and is summarized in the following sentence. Just ask a representative sample shortly before the policy meeting what they would do or think, I'll get to that, under policy A, and what they would do or think under policy B. And then from their answers, what they would do differently in these two policies, under these two policies, you compute what's going to happen in the economy under these two different policies. So that's the key idea. Now, more formally, what we're going to do is we're going to take a standard DSGE model, and we're going to focus on households for the moment. The key variable that we're interested in will be consumption. And we just take out the standard consumption part out of a DSGE model. And then we're going to express consumption of households that are not borrowing constrained as a function of expectations only. So it turns out quite generally in these models, when you're not borrowing constrained, your consumption will be a function of the expected income path, of the expected interest rate path, and your perceived wealth. That will be a standard consumption function that will come out of a standard model. And then we're going to run a survey and we're going to elicit all beliefs that appear or expectations that appear in this consumption function, not for one policy, but for two policies, policy A and policy B. And then we have households' expected income path under the baseline policy, households' expected income path under the alternative policies. We feed these two into the consumption function, and there we compute the difference in consumption across these two policies. And we aggregate up, and that will give us the aggregate consumption counterfactual. So what's our forecast of how consumption will be different under policy A than under policy B? Now, returning to the sentence here, so what we do there, we ask a representative sample of households shortly before the policy meetings what the expected income path, etc., is under policy A and what the expected income path is under policy B. Of course, we can also directly ask them about actions, and we're going to do that at the end of the paper. So an alternative is we simply ask individuals, how much would you consume under policy A, and how much would you consume under policy B? Compute the difference. That's the effect of implementing one policy rather than the other one. On individual consumption, we aggregate up, we compute aggregate consumption. So there are two ways of doing that. We actually implement both approaches, and then at the end, I'm going to show you whether that gives different results. Kind of a quick summary is going to be results will be quite similar, whether you ask people for their expectations and feed them into a consumption function, or you ask them directly for their consumption under these two policies. So let me illustrate that idea with an extremely simple example. That's, of course, much simpler than the model we're going to have, but many macro models, they imply equations of the following form. There's some outcome variable y, think of that as consumption, and then there's some endogenous variable x. Think about lifetime income. It's a variable it's endogenous in the model. And that endogenous variable lifetime income depends on policy Z. And there's some equation in the model that says consumption depends on the expectation of lifetime income. And 1 minus beta here would be the marginal propensity to consume. Now, suppose you take a model and you compute the effect of policy Z on consumption, while you just take the derivative on the left-hand side, you take the derivative on the right-hand side. So the derivative of consumption with respect to policy here in the simple example is just the derivative of the expectation of lifetime income with respect to policy. And then in the model, you have some assumptions to compute that derivative. For example, you assume that agents have complete information, so they know which policy is in place. And also they have rational expectations, so they're right about how the distribution of lifetime income moves with policy. And that would be a combination of assumptions which would give you this effect of the policy on the expectation of lifetime income. So knowing the policy and having rational expectation, and then that would give you, together with that equation, the consumption. So that's what you usually do if you compute these policy counterfactuals with the model. Instead, what we're going to do is we're directly going to elicit these expectations. So we're directly going to ask people, what's the expectation of your lifetime income under policy A that's on the table? What's the expectation of lifetime income under policy B that's on the table? And then we're going to feed it into an equation of that form and directly compute, and then compute consumption. And the advantage of doing that is that you don't have to make assumptions how expectations are formed. Instead, we use measured expectations directly, what people are telling us what their expectations would be under these two policies to feed them into this kind of equation.
Okay. Mirko, I'll just ask one quick question here. So I guess I'm now going to be able to properly interpret then what you just said at the end of the last slide. So one thing with this, just doing the, what is your belief, your expectation under policy A and policy B, is that then you're relying on the model to tell you what the implied effect is. And so what you were really saying at the end is, if you directly ask them, what do you think the change in consumption is, it's sort of also a test of how whatever model you're going to propose about how it approximates people's beliefs about the state of the world. Is that a fair statement of what you're going to say?
That's a fair statement, yeah. And I'm going to show you how well that works at the end. So you can, if you see the first equation here on this slide. So what we're going to do initially, we're going to elicit the right-hand side on the two policies and compute the left-hand side, and later we're going to elicit the left-hand side on the two policies. And so, and then we're doing both, so we can also evaluate how well that equation works actually.
Okay, yeah, okay, cool, thanks.
And that's what I meant here by do and think. So when we elicit the right-hand side, we ask individuals what they think on the policy A, and if we elicit the left-hand side, we elicit what they would do on the policy A. Okay, let me give you a very quick kind of summary of how that relates to the literature. I have that on the following slide, but let me actually do it here on this slide. So of course, this relates to the literature that uses DSGE models to compute policy counterfactuals. And the difference is that we are not going to make assumptions about how expectations are formed. So we don't take a stand whether people have rational expectations or complete information, and exactly what deviation from rational expectations or complete information is the right one. Instead, we're directly going to elicit these expectations under the two policies and feed them into the model. And then with respect to the kind of large literature that studies how households form expectations, the difference is that so some papers, they have actually elicited expectations under alternative policies. But what we do differently is that we start from the consumption function and we ask, what are all the expectations you would need to know in order to actually compute the left-hand side? And so we elicit many more expectations and under alternative policies, and we constrain ourselves by saying, okay, let's just start from theory. Which expectations would we like to know? Expectations of the income path, expectations of the interest rate path, the inflation path, and so on. Elicit those under alternative policies. And then this allows us to compute a policy counterfactual to say, like, consumption would be 1% lower under policy B than instead of policy A. So we elicit enough expectations to make that calculation. Okay, let me go now more into the details. So as I said, we take a standard DSGE model. We take out the consumption side of that DSGE model. So here in period T, each household I chooses consumption, CIT, and hours worked, NIT, so as to maximize the expected discounted sum of period utility. Period utility is increasing in consumption and decreasing in hours worked. And then there's a standard flow budget constraint. Agents have interest income, labor income, dividend income. They pay taxes. These are the resources that they have available, and they can either use them to buy consumption goods or to save. And now what's new is when we come to expectation. So here you see an expectation operator. And normally the first thing you would do is that you would specify, make some assumptions about beliefs. So for example, you would assume agents know everything that has happened today. You would assume they have rational expectations. So their perceived law of motion equals the actual law of motion and so on. We don't do any of that. We just make the following assumptions about beliefs. So we say this expectation is some subjective expectation, so it's computed with some subjective probabilities. We don't say anything where they are coming from, and we don't place any restrictions on them. And then to solve the consumption savings problem, you need to give this household a bit of understanding of the structure of the problem. So the household believes that this flow budget constraint has the same structure in future periods. So in particular, they understand that if they save today, they're going to earn interest, and that allows them to consume more tomorrow. And we also assume that the household believes that it cannot run a Ponzi scheme, because the moment they think they can run a Ponzi scheme, they would, of course, consume very different amounts. So these are the only assumptions we're going to make about beliefs. And then just based on these three assumptions, you can derive an equation that characterizes today's consumption implicitly. You can log linearize that equation around some point, and then, you can log linearize that equation that defines consumption implicitly around some point, and then you get the following log linearized consumption function of a household. And this is consumption of individual I in period t expressed as a log deviation from the point around which you're log linearizing this equation that characterizes consumption. And it says consumption depends on the expectation of that individual at that point in time of the after-tax income path. So here y tilde I comma s is the after-tax income in real terms that the individual has in period t, t+1, and so on. And your consumption today depends on the expectation of your after-tax income path. And it also depends on your perceived wealth. This is the term down here. This is a one asset economy, so they're carrying bonds into the period. And this is what they think the real value of their beginning of period wealth is. Also, that's the other thing that affects consumption. So that's this consumption. We sometimes say this is consumption out of human wealth. This is consumption out of financial wealth. And then since they have the possibility to consume and save, what also matters is the interest rate. And this is the intertemporal substitution term. So consumption also depends on the expected discounted path of current and future real interest rate. This is the nominal interest rate. This is the real interest rate. So the standard theory, once you just write it in this way, you don't make assumptions about expectations. You just characterize consumption implicitly. You log linearize it. It just says consumption depends on the expected income path, depends on your perceived wealth, and depends on the expected interest rate path. And 1 minus beta is the marginal propensity to consume, and 1 over gamma is the intertemporal elasticity of substitution. And then
so Mirko, there's one question that's come in from Tommaso, which asks, does this mean that there are no higher order beliefs of how other households are forming expectations?
No, the only thing that you need is first order beliefs of endogenous variables. That's the only thing. Consumption just depends on first order beliefs of endogenous variables. In a model, all these things are endogenous. Your own income is endogenous. Interest rates are endogenous. Think of a Taylor rule. Inflation is endogenous. Think of some, you have a New Keynesian Phillips curve in the background. The real value of your assets is endogenous. Everything is endogenous, but there's an equation in the model, and this equation is always there in the background. We just normally don't write it like this, is that consumption depends on your expected income path, expected interest rate path, and your perceived wealth.
And just to follow that up though, because I think the second bullet is the key one here. The point around which you log linearize also doesn't really matter because you difference that out. Is that correct?
Exactly. That's the second point. So now think about how your consumption of individual I would be at point T under two different policies. Now, of course, in the end, only one of them is going to be implemented, but you're interested now, ahead before the policy meeting, you're interested, what would be the difference in consumption? So you just write this equation at two different policies. So you just give it a superscript policy A, policy B, and then you notice your preferences are going to be the same under the two policies. The only thing that differs is these expectations under the two policies. And then you're exactly right. The moment you do the difference, the point around which you log linearized difference is out, which is a nice feature. You still have it in here. This is your, think of this as the consumption relative to income and consumption relative to wealth in the steady state. And now what we're going to do is we're just going to do this equation and we're going to elicit the objects that are in there. So we're going to ask people, what is your expected income this calendar year, next calendar year, and so on under policy A, under policy B. We ask them for alternative horizons. We compute this term. We do the same for interest rate, inflation. And then we ask people about how much they normally consume relative to income. This gives us this term, and what their wealth is, and this gives us this term. And then we elicit these things, and we compute the consumption difference across policies. And kind of intuitively, what it's going to do is just when people tell us, well, under this the higher interest rate policy, you know, I'm just more pessimistic about my income. That's what they're telling us. We feed that into this equation. It's telling us they're going to consume less under that policy. And we do that for each individual. So note that here's the difference in expectations across policies are sufficient statistics for computing the consumption difference across policies. That's what we're going to do. And this is when we ask people what they think under the two policies. And then in the alternative implementation, we directly ask them what they would do under the two policies. And then we compare also that. Okay. Then the final step is aggregation. We aggregate these individual consumption differences to obtain the aggregate consumption difference. And that will be a number. So already on the individual level, it's a number because these are log differences across two policies. So this will, for example, say for this particular individual, they would consume 1% more under that policy. And then this is true for each individual. We sum up, and this is going to give us an aggregate consumption difference. So it's going to say under policy A versus policy B, aggregate consumption will be, I don't know, 50 basis points lower. And then again, difference to the literature is that the literature on DSGE models often has the exact same equation in there. You just don't see it so clear. It's in the background. And these expectations are computed with the model. And here we directly elicit them. And the difference to the survey literature, information provision experiments, and so on. Sometimes you elicit expectations on alternative policies, but here we elicit all of them that appear in this consumption function to be able to do that calculation.
Mirko, as well as the aggregation, does this also allow you to look at heterogeneity?
Yeah, we do. So we see a lot of heterogeneity. So we see, for example, we see a lot of so for us, the baseline policy will often be no change in the interest rate, and then the alternative policy will be an interest rate increase, let's say 50 basis points. And you have some people who say, well, under the higher interest rate, my income will be higher. And you have some people who say, under the higher interest rate, my income will be lower. And the same for inflation and so on.
But do you know enough about the subjects or the respondents that you can say, the person who said my income will be higher is someone who's 70 years old, has a large stock of fixed income assets, and is therefore actually going to gain from higher interest rates? And it's the person with the mortgage who suffers.
Yeah, so we ask people about their portfolios and we ask demographics and so on. So we could dig deeper into that. We haven't done that so much yet. But we would definitely be interesting to do that. So we applied this approach 3 times and to study the effects of unconventional monetary policy and to study the effects of conventional policy. We wanted to demonstrate how to do this. And what we did each time is we ran a survey about 2 weeks before the policy meeting. And then we tried to guess which kind of policies were on the table at the Fed at the time. We did this in the US. And of course, we don't know exactly, so we try to guess. But in March 2021, interest rates were at 0. And we thought, well, they're not going to raise interest rates in March 2021. So we thought the alternative policy was maybe a forward guidance statement. So the baseline was keeping interest rate constant, no forward guidance statement. The alternative was keeping interest rates constant and a forward guidance statement saying that 2 years from now, we expect the interest rate to be 40 basis points higher. And so these were the two policies that for which we asked people their income expectations and so on. And then we did this again a year later, March 2022. At the time, interest rates were still at 0, but there were discussions about the liftoff. So the alternative policy was an interest rate increase, I think, by 50 basis points. And the baseline policy was to keep interest rates at 0. And then we did it again in September 2022, and their interest rates were already at, I think, 2-point-something%. And so the baseline policy was keep interest rates unchanged, and then the alternative policy raise interest rates even more. And today I'm just going to talk about the September 2022 survey that we did, just in the interest of time. So this survey was conducted as an online survey about 2 weeks before the FOMC meeting on September 2021. This was done in collaboration with the panel data provider Prolific. The sample is about 1,000 households who are roughly representative according to observables. And then the structure of the survey is that we first collected some demographics. We then told people that we were interested in how they thought about the US economy, and we gave them a very brief definition of the federal funds rate and of the inflation rate. We then presented them with the policy B, the baseline scenario. I'll show you the wording, and we asked them for their income, interest, and inflation expectations. Then we said, well, now imagine you hear a different policy, the alternative policy. I'll show you the wording, and then we elicited the same expectations. And then afterwards, we elicited many other things. So we elicited their portfolios and so on. Let me show you the wording. So respondents first complete the baseline scenario where they receive the following instructions. Please imagine that at the next meeting of the Fed on September 2021, the Fed decides to keep the current federal funds rate unchanged at 2.4%. Imagine also that the Fed's projection for the federal funds rate at the end of 2031 remains unchanged for 2.5%. Imagine you actually hear the announcement. Upon hearing the announcement, what would be your expectation of your income this year, income next year, income in the following year, and so on? And what would be your expectation of the interest rate at the end of this year, the following year, and so on? Then people are confronted with the alternative scenario. Please imagine that at the next meeting of the Fed decides to increase the current federal funds rate from 2.4 to 3.1%. Imagine again that the Fed's projection for the federal funds rate at the end of 2031 remain unchanged. If on the day or conditional on hearing this announcement, what would be your expectation of your income this calendar year, next calendar year, and so on. And so that's the key information that we use to compute the policy counterfactual.
Sorry, Mirko, can I ask a question here? Did you give them any background what the Fed is and what the federal funds rate is? And I mean, federal funds rate might be something that's not familiar to people.
Yeah, exactly. We try to keep it very short. So we told them that the Fed sets the federal funds rate, and that this is an interest rate that affects interest rates on savings and on debt and so on. I think we had 3 sentences, if I remember correctly. And then we had 1 or 2 sentences on inflation. We said that inflation is the extent to which prices change expressed in percentage terms or so. I don't remember the exact wording anymore right now. But
they might not know that the Fed would actually have a different policy path because there is also a different underlying inflation path. So,
no. So, I mean, we tried in the end, the assumption will be that the expectations that they now tell us they have, conditional on hearing this, would be also the expectation that they would have if they heard this on the news. So we kind of, we would like to, in some way, simulate that experience, of learning about this on the news or in the news media or somewhat. So one could think about so we wanted to not give them information that would make them have different beliefs than they would have if from just hearing it on the news.
Right.
I mean, one could work more about this. So unfortunately, now I don't remember the exact wording that we used to explain the Fed funds rate, but the inflation rate. But the idea would be to not make this any different from learning about this from reading the newspaper or going on some website.
And just another sort of quick question on how you implemented it. Did you do much variation in the order in which they saw the scenarios? So I mean, you could imagine if you're told interest rates will go up, and then suddenly the alternative is they don't go up, that might change someone's feelings. I don't know if the order matters for this.
No, we did not, but we could definitely do that. Yeah.
Okay.
So here's a table that summarizes the answers that people gave on average across households. This is a survey that's done in September of 2022. And what you see here in the different columns is the different horizons that we asked them about. For example, we asked them, what do you think the federal funds rate is going to be at the end of this calendar year, at the end of next calendar year, at the end of that calendar year, at the end of 2027, at the end of 2031. So we elicited 5 interest rate expectations. And then the delta is the difference between the alternative scenario and the baseline scenario. Remember, the alternative scenario is they're told the Fed raised interest rates by, I think, 60 basis points. And then people say, well, on average, they say, I expect the interest rate to be 62 basis points higher at the end of this calendar year. I still expect it 60 basis points higher at the end of next calendar year, at the end of the following calendar year, and so on, and so on. And then we asked them, what do you think the inflation rate will be for this calendar year? And this is, again, the difference between the expected inflation rate under the high interest rate scenario relative to the no interest rate. And people expect higher inflation rates upon hearing higher interest rates. And in the current year and also in future years. So they take that higher interest rate somehow as a signal of inflationary pressure maybe in the economy. That would be one way to interpret this. We don't know how to interpret it. It's also for the exercise, it's irrelevant. But here they say, well, if we hear the Fed has decided to increase interest rates by 60 basis points, we have higher inflation expectations. And then we ask them about their own income. And they say for the current calendar year, they, on average across all households, they expect to have 0.5% lower nominal income under the higher interest rates. And then the fact that you see a hole in here just means we ask them about the average over these years and so on. And they also expect to have lower income in the future, quite far in the future, under the lower interest rates. So the content of the policy announcement affects households' expectations of the policy rate, inflation, and nominal income. And when we did this in September 2022, they told us, well, under the higher interest rate announcement, I expect lower nominal income, I expect higher inflation, and I expect higher interest rate. And all of that quite persistent into the future.
Can I ask another?
So Mirko, sorry, go ahead, Michael.
Okay. I mean, in the notes, and you mentioned this before already, you apply this strictly to non-hand-to-mouth households, right? And I presume precisely because then they get into constraints, and then the delta is no longer so easy, right? But so how do you define those? Because they could become hand-to-mouth if in a different policy scenario. So
yeah. So I explain that more detail on a following slide, but let me already kind of give you a quick answer to that question. So we elicit, after they have told us about the expectations under the 2 scenarios, we asked them about their liquid wealth and about their revolving credit card debt. And based on that, we do the standard Kaplan-Weidner-Violante classification. We classify them as hand-to-mouth or not hand-to-mouth. And if they are hand-to-mouth, we assume that their consumption would only depend on income, would not vary with expectations. And then we also ask people about their subjective probability of becoming borrowing constrained in the future. And, you know, that's also important in these Hank models. It's not only whether you're currently hand-to-mouth, but whether you expect the borrowing constraint to be binding in the future. And that makes you, in some sense, shortens your horizon. And so we use a different consumption function for people who have a high subjective probability of becoming borrowing constrained in the future. And we use that actually in the calculation when we compute these deltas. But it's just not in this table. So here we only show these differences in expectations, and then here we restrict the sample to non-hand-to-mouth households. We also elicit the expectations for the hand-to-mouth households, and I can show you. I could construct a similar table for them, but they're going to feed differently into the model. They're used differently in the model. Yeah.
So just two little things from me. One is, I know it doesn't matter for you, but how good were their levels? Like, were they, you know, like on federal funds rate, if they see it's going up by 60 basis points,
yeah,
did they, because you didn't ask them about the difference, you asked them about the level. Did they give like, did they go bonkers? Did they go to 20% and 20.6%? Or are they more restrained? And the second one is just a comment, which is, you know, there's a quite often finding, and, you know, Ollie, Yuri, and Michael Weber, and I think Francesco have this paper where they sort of show that households generally associate high inflation with bad things. So you know, if you ask professional forecasters or firms, they say, you know, low growth, low inflation, high growth, high inflation, and households do the exact opposite very robustly. Maybe they just have this high inflation is bad and it happens with bad things, and high interest rates are bad because it lowers their income. That's a comment, but I would be interested if their level is any good. And then when you're done with that, I have one more question from the floor, which I'll ask and then let you carry on.
Yeah, sure. So on the level, the federal funds rate, they give answers that are very similar to the policies they're confronted with. You know, if they are told the interest, the federal funds rate is going to be 3.1% under the alternative scenario, and then they take something that's around 3.1. A lot of them know, and project that into the future to some extent.
Okay.
And income, people give kind of very precise answers in the set of detailed answers. So they say, I expect my income this calendar year to be, and then they give a kind of a pretty detailed answer. And we first ask them in terms of brackets, and then they fill in an exact number. Inflation, I don't remember anymore, unfortunately, and I should know. I would have to look this up. Yeah.
Okay, that was fine. Anton has a question from the floor. Are you sure they answered about their nominal income? Under increased inflation, what they thought of might be indeed the cumulative real income.
Yeah, we try to make explicit that, so we have a fairly long explanation of what we mean by income, because in the model, this is your total after-tax income. So we list all the income sources. We also, it's important that this is after-tax. Remember, in the Hank literature, it's important what you assume about fiscal policy, because it's after-tax income that matters. And then we also tell them this is your dollar income this calendar year. And I mean, I'm not sure we tell them we don't tell them, 5 years from now, this should be in 5 years from now dollars, but my guess would be that this is pretty clear. It's all in dollars. But yeah, we could, again, you could vary this and maybe let's try to do it differently and see whether it matters, how the question was phrased. Yeah. I mean, it's an important point, because here you see, if you just think on average across these households, they think these high interest rates are pretty bad for them. No, it's on average, they think that their income is going to fall by 0.5%. In nominal terms. On top of that, you have 0.5 percentage points higher inflation. So that means if you combine this two, in terms of real income, this calendar year, they expect their real income to be 1% lower. So already from these numbers, you can tell the consumption differences I'm going to show you, they're going to be sizable, or they're not going to be small. So let me just emphasize one point before I get to the consumption differences. We did this 3 times. And what we found interesting is that in each case, the alternative was phrased as a higher interest rate. So in 2021, this was forward guidance. So it was higher interest rate in the sense from now the Fed announces that 2 years from now, the interest rate is going to be 40 basis points higher. Here, the current interest rate was either 0 or 50 basis points. And here it was either 2.4% or 3.1%. So it's always baseline low interest rate, alternative high interest rate. And then what we found is that in March, on the high interest rate scenario, they had lower inflation expectations. Here, a year later, under the high interest rate, they had higher inflation expectations. And here, under the high interest rate, they have higher inflation expectations. So if you interpret this in terms of theory, here, no signaling channel of monetary policy. And here, somehow they start to take this as a signal of inflationary pressure. And also when it comes to income, in March 2021, actually under the 2 interest rate scenarios, on average, they had the same nominal income expectations. Also a year later, and then September 2022, under the high interest rate scenario, they had lower nominal income expectations. So just how kind of differences in policy translate into differences in expectations, even just qualitatively, in terms of science, varies quite a little over time. And you can ex post rationalize it. So you can say, here there was this discussion about whether inflation was here to stay. And then when the Fed raises the interest rate, people probably take that as a signal of inflation is here to stay. Here there was this discussion. Powell gave this speech at the Jackson Hole conference saying that interest rate increases are going to be painful for households. And this is the first time that people say, well, under the high interest rate, my income is going to be lower. So kind of you can ex post rationalize it. We don't know if these are the explanations, but it could be. But I think what we think is important is that there appears to be state contingency in how expectations differ across policies, even just in terms of sign. And this method allows you to identify the state contingency before the policy meeting, because the survey is done before the policy meeting. So you can say, based on the survey, we are now at a time where a high interest rate is taken as a sign of inflationary pressure. Or we are now in a world where a high interest rate is not, people don't associate that with lower nominal income. And you identify that ahead of time.
So Mirko, I'm gonna throw one more in just because Luca has asked it. But he asked, have you tried to follow up with the respondents and see if once the hypothetical scenario is realized, their answers coincide with their pre-announcement survey? Consumers might change their expectations after observing what happens to them or seeing TV or whatever.
I think we should do that at some point. So that would be nice to do. At the end, of course, always just one of the 2 policies is implemented, but we could elicit expectations just under that implemented policy and compare that to the answer to the question that they gave. Imagine you hear that policy, what would be your expectations? So,
just to confirm though, that each of these 3 treatments, these were different surveys. They're not the same households that you followed each time.
No.
Yeah, fine. Yeah. Okay, good.
No, but I think it's a good idea by what Lucas suggested to follow up, and then one policy is implemented, elicit expectations under that policy, and compare that to the answers that they give actually before the policy meeting. Now, I think it's a very good idea. So then now we can compute the consumption differences across policies. You just need 2 parameters, the discount factor and the intertemporal elasticity of substitution. We set the first one 2.99, the second one to 1/2. And then here the key assumption is, already came up now. So the key assumption is that these expectations differences across policies equal the elicited expectation differences across policies. So what they are telling us 2 weeks before the policy meeting, what their expectation about own income would be conditional on hearing policy A is actually what the expectation of income is 2 weeks later, conditional on hearing policy A. That's the assumption you need to make. And then you can just feed this in, and then feeding each household's expectation data into the consumption function and aggregating yields that under this alternative policy, which was 60 basis point higher interest rate, aggregate consumption would be almost 3 percentage points lower. And that is just because they're telling us, lots of things are bad for them under the higher interest rate. They have lower nominal income expectations, they have higher inflation expectations, and then on top of that, there's intertemporal substitution because they have higher interest rates. So there's a lot of things that pushes them to consume less under the higher interest rates. And then I'm going to get to that in more detail on the following slide, but we classify households as being attentive or non-inattentive, and then we assume, well, only the attentive households would actually respond to the announcement because only they would be aware of it. And that if you take that into account, then the effect roughly is reduced by half. Because roughly half of their households, we classify them as being inattentive. They would just not hear the announcement. And then the effect on aggregate consumption is a bit less than 1.5%. The difference between policies. How much time do I have left, roughly?
We have so you should be definitely done in 15 minutes.
In
so
15 minutes. Okay.
we could. You've had lots of interruptions, and so
okay.
So we go to the full. But let me use the interruption to do another one, because Julian just asked, how can you mitigate potential concerns about experiment or demand effects in your context? So people report bigger changes because they feel they have to do so. You may want to defer that to the end if you want.
Yeah, I think I have to defer that question to my co-authors. I'm sorry, I'm not an expert on that, so I could say something, but I don't think it would be fair. I think that question should go to my co-authors. They're telling me they're not concerned about this, obviously, but and Chris Roth has a paper in the AER about experimental demand effects. So I think he's in principle of course aware of that issue, but yeah, I'm not the one who could give the answer.
That's fair. Okay.
Okay, so let me just, at this point where we have the numbers, contrast that a little bit. So of course you could get a number like that out of a DSGE model. What would you do? You would write down the entire DSGE model, you would feed in policy A, policy B, you would get the aggregate consumption difference. For example, take your favorite New Keynesian model. What's the difference? The difference is, of course, much fewer assumptions. So we didn't make any assumptions about expectation formation, because these income expectations and so on, they're not computed from the model, they're taken from the survey. And what's the cost? There's always the trade-off. No, the cost is that what we compute is the impact effect. So now in a model, you would compute an impulse response function. But for that, we would need to know what these expectations are in the following quarter, and so on. But our survey is not giving us that. And then compared to the literature on running surveys in order to understand how households form expectations, well, they sometimes elicit, for example, inflation expectations under two different policies, but there's always some missing expectations. If you just think from the point of view of the consumption function, you always just elicit some of these expectations. And here the key idea was start with the consumption function, ask which are all the expectations we would like to know, elicit them for the different policies, and then we can actually compute a number like that. And this is also what brought us to this project. We love this literature and we had read many of these papers, but the question was always, okay, so what's the implication for a simple question like what would be consumption under policy A and policy B? And so we try to fill in this gap by just starting from the theory, eliciting more expectations, and then being able to compute a number like that. Okay, let me go a little bit into heterogeneity. I think I gave a quick answer to that before, so let me just read it out. So there's a lot of heterogeneity in expectations in the survey already, and we use that, but there also might be other types of heterogeneity. For example, hand-to-mouth versus non-hand-to-mouth households. So what we do is we elicit households' liquid wealth, the revolving credit card debt, and their subjective probability of becoming borrowing constrained. And then we use a different consumption function for the hand-to-mouth households, and also for the households that have a high subjective probability of becoming borrowing constrained in the future. And so this is a heterogeneity in consumption functions. Theory would say they have different consumption functions, and we try to take that into account. And then there's also this heterogeneity, attentive versus inattentive households. So we ask people, what is the expectation of your income conditional on hearing? But many people might just not hear. And so you can think about the movement in the expectation is a dummy variable, whether they're here, times how the expectation would move conditional on hearing. And so we classify households as attentive or inattentive. We ask them, how long would it take you to hear about the policy decision? And then if they say, I would hear it within 7 days, we classify them attentive. And then we also have a quiz where they will ask them, when was the last time that the Fed changed the interest rate? And then based on that quiz, we also classify people as attentive or not. And then we check whether there's a correlation between these ways of classifying people, and the correlation is quite high. And then we assume that the inattentive households, they would just not hear the announcement, and therefore they would also not respond with their beliefs and their consumption to the announcement. And that gave the second number, the smaller number that I showed. So now in the last, I guess, 10 minutes, I want to talk about asking people directly about what they would do. And we do that in the same survey. So we can actually compare these two approaches directly. For the same household, we have what the expectations are under the two policies, compute the implied consumption, and we directly ask them, what would you consume under these two policies? So after completing the two scenarios, we remind our respondents of the federal funds rate in the two scenarios, 2.4% versus 3.1%. And then we ask our respondents under which scenario their household would make fewer purchases of non-durable goods and services. And the answer options are, I would consume less in the no change scenario. This is the low interest rate scenario. I would consume the same in the two scenarios, or I would consume less in the high interest rate scenario. And then we also ask our respondents about different aspects of their spending behavior, but let me just focus on that very simple question. And then one can do the following exercise. So on the right-hand side of that figure, you just see the answers that people are giving, or the frequency of answers. So this was, so roughly 50% said they would consume less in the high interest rate scenario. 40% said they would consume the same in the two scenarios. And about 10% said they would consume less in the low interest rate scenario. So this is just the frequency of answers to these consumption questions. Now one can ask, what's the corresponding number when I ask people about their expectations and feed it into the consumption function? And that's the left-hand side. So that's computed from the model and from the expectation answers. And so in the model, we get this number, this delta CI. If it's negative, it says people would consume less under the high interest rate scenario. If it's positive, it would say people consume more under the high interest rate, so less under the low interest rate scenario. And then we said, well, we don't really have households in there that would consume exactly the same under the two scenarios. That would be extremely unlikely. So we say people that would consume very similar amounts under the two scenarios, we classify them as equal across the two scenarios. And we say people who had this delta CI, which was plus minus percent, minus 1%, ones that are in that interval, we say, well, in a survey, when they're directly asked about consumption, they would probably say they consume an equal amount across the scenarios. And then this is what you get from asking people about what they would do. And this is what you get if you ask people about what they think, so their expectations, and feeding it through the consumption function. And so the model-based consumption responses fit the aggregate pattern of the self-reported consumption responses. But this is just like a first step. So now let me go into more detail, because now the key question, of course, is the following. Are the individuals, the households that are telling us they would consume less under the high interest rates scenario also the ones that are giving us expectations that give us, according to the consumption function, consumption that is lower according to the high interest rate scenarios? So are the individuals in here also the individuals in here? Or if you start from the model side, if someone told us, oh, I expect my income to be very low under the high interest rates, when I ask them about consumption, do they also say, well, I would consume less under high interest rates? And so we look at that, whether that cross-sectional pattern is here. And that's the last slide I'm going to present, and let me go a little bit into details. So what we do is for each individual, we have the delta CI from the model and the expectation answers. And so for an individual which has a delta CI of here -5%, this says the expectation answers plus the consumption function says they should consume 5% less under the high interest rate scenario. And then here, these are all the individuals in that bin, which according to the expectation answers and the model, they should consume 10% less under high interest rates. And these are all the individuals which, according to the expectation answers and the model, would consume 15% less under the high interest rate. And what you would expect if this works is that as you go to the left, more and more of the people in that bin say, I consume less under the high interest rate scenario. So you would expect a negative slope, and this is what you see. If you go into this territory where the model says, well, these individuals, they should consume a lot less under the high interest rate. Also, the frequency of saying I consume less under high interest rate is going up. So people where the model is saying they would consume less under high interest rates, they also they're more likely to say I would consume less under high interest rates. And that's consuming. So this is, in terms of what I showed you before, this is the right-hand side of the equation, or then the computed left-hand side, and this is directly eliciting the left-hand side, but in this qualitative way of just saying, would you consume less on high interest rates? And now I can ask, so where's this fit coming from? From which type of households is this coming from? And this is where we go to B and C, and we can do that in many different ways because we, collected lots of information about these households. But here we just ask, well, let's focus on non-hand-to-mouth households because according to the theory, this should come from non-hand-to-mouth households, not the hand-to-mouth households. They should have consumption equal to income. Expectation should be irrelevant. But what we find is that here the slope of the line is the same, whether we do that only for the non-hand-to-mouth households or the full sample. So it doesn't seem like this equation that I showed you works any better for non-hand-to-mouth households than for hand-to-mouth households, or a different way of saying it, it doesn't work worse for hand-to-mouth households than for non-hand-to-mouth households. It really works the same for hand-to-mouth households. So whether they have what their liquid wealth is and what their revolving credit card debt is doesn't have any influence about how well this works. How well you can predict these answers to the consumption question with this consumption function I showed you before and the expectation answers. What works really well is when you now split the sample differently and only look at the attentive households. Then you see that the slope is becoming steeper. And so for these households, it works really well. So where the model is saying, well, they should consume much less under the high interest rate scenario, they are also much likely to say that they would consume less on a high interest rate. And the magnitudes are non-trivial. So here in this box, in this bin, 30% of households are saying I would consume less under the high interest rate scenario. And here, 70% of households are saying I would consume less under low interest rate scenario. So the model-based consumption responses are strongly correlated with these self-reported consumption responses across respondents. So our takeaway from that is it's not completely relevant whether you elicit what they think under the two scenarios and feed it to a consumption function, or you just ask them about what they would consume. But the aggregate pattern is similar, and in the cross section there's this pretty strong correlation. And I think, Michael, this was. I hope this is. That's understood what you had in mind. Now that one uses also this kind of data to actually, in some sense, test this equation. Does this equation work in predicting, what people would answer to the consumption question? Okay, I think I'm out of time. Let me just conclude. So suppose you work at a central bank, you would like to know ahead of a policy meeting what is the effect of implementing policy A instead of policy B. What we propose is a new approach to answer this question. So just ask a representative sample shortly before the policy meeting what they would do or think on the policy A and what they would do or think on the policy B. and then compute the consumption counterfactual on the individual level, aggregate it up, and compute the aggregate consumption counterfactual. We applied this approach to study the effects of unconventional and conventional monetary policy. So we did this overall 3 times so far. And then what we found is quite sizable effects of monetary policy on consumption. So in the wave that I showed you, it was 60 basis point higher interest rate implied 1.5 percentage points lower aggregate consumption. We find very large heterogeneity. So even if you just focus on the high interest rates, do people expect higher income or lower income? This varies across individuals and actually quite a bit. No, so there's a lot of heterogeneity in there. There's different from this heterogeneity. Are you hand to mouth, non-hand to mouth, and so on. And we also find some evidence of state contingency. So I'm cautious here. I mean, some evidence, it wasn't the exact same policy alternatives we confronted people with at different points in time, but there was always a low and a high interest rate. And we found that even qualitatively, whether expectations were higher under high interest rates or low interest rate, varied quite a bit across time, and also whether their income expectations were different under these 2 policies.
Great, perfect. Well, we've completed the hour, but we always leave up to 15 minutes for further discussion. So if people do still have questions, put them in. I'm going to throw, so I find this stuff fascinating. I think it's really cool. I'm going to throw in one sort of, I sort of alluded to it earlier, but I do think exploring the heterogeneity, in terms of like, do people with mortgages say that it's going to be worse for them? Do people with large savings think, this is, fantastic? So I think that heterogeneity would be super nice. I think it'd be also very cool because in theory, you have some households who say that consumption will go up and some that say consumption will go down. It's sort of neat that you can look at the sort of kernel densities, and I think that would be very cool. The really adventurous policy to sort of properly test the extent before you send Michael Ehrman off to do this before every policy meeting in the ECB's cool new survey. I guess one thing that would be cool, maybe relates a little bit to Luca's point earlier, and I see some extra questions coming in, so we can turn to those in a minute. But the community of people who study this stuff, or just to get scale, you could in theory do this across lots of countries at lots of different policy decisions, and sort of see ex post, because ex post, if so long as you don't get it completely wrong what the 2 options are, one will be chosen. And then you can look, 6 months or a year later, you can look what actually happened to aggregate consumption. Now, of course, you're right, these are not the same things, because one of them is the impact expectation of what will happen over the next year, and then there'll be some shocks. But if you had enough data and you could sort of measure the shocks a bit, you could actually really see how accurate these people were at guiding the future evolution of the economy. Because in a sense, if you do a representative sample, these are the economy. These are, households. These are 70% of economic, 60 to 70% of economic activity. Excuse me. I don't know if Michael Ehrman has other comments he wants to make at this point, but yeah, Michael, you've unmuted, so I'm taking that as a comment.
I have a quick question. I mean, you showed these slopes in the end, how sort of, the elicited versus the direct question sort of matches up. And you showed sort of a very tight relationship for the attentive people. Now, you sort of said, at least in one part, this was the quiz, right? So these were people who actually knew when the Fed had changed rates earlier. So I was wondering whether that could also be a proxy for financial or economic literacy or central bank literacy. So are these people just understanding very, very better? And if I look at this slope, it's very tight, so the rest can be extremely noisy. So are the others just giving you a lot of noise? Because they maybe just don't understand the concept. So do you have another way of getting at financial literacy here?
Yeah. Shall I answer immediately?
Sorry, yes, I was on mute, but yes, far away.
Shall I answer immediately?
Yeah, if you can. Yeah.
Okay. So let me start with the heterogeneity question. So, I mean, I totally agree with Michael McMahon. I think it would be great to just understand that a bit better now, and like, who are the people who say high interest rates, under high interest rate, they say I expect higher income than under low interest rates, and then there's to see whether maybe that also lines up with economic theory. And I think that would be really interesting to do. And we don't know, we've collected lots of data and we haven't digged very deep into these aspects of it, but I think it will be extremely interesting to do. And we asked people about housing too. So in principle, we have some information also on housing, and we have on the portfolios, we did ask them about assets and liabilities, but not as detailed as you would do it if this were the focus of the paper. So, but we asked people about it to some extent. So, yeah, we can try to understand whether the heterogeneity we see links to observable characteristics of these households. I think that would be very interesting. And then I also really like the other idea of just, if we're lucky and one of these policies is implemented, to just go ex post, run the survey again, and you don't have to now ask people about the expectations on the two policies, but just under that one policy that have been implemented, and then compare that to what they said they would expect if that policy were implemented. So I think that would be a pretty clean exercise and pretty natural given the approach that we are suggesting. And then, yeah, it would also be nice to see afterwards what happens to consumption, but also what happens to the things that they are forecasting, so their own income and so on. People. So we were quite surprised initially in the first two waves that people on average said higher interest rates doesn't affect my own income in nominal terms. We were quite surprised to see that. I don't know of any model that has that feature. Yeah, so comparing what people are saying to what actually happens subsequently, I think would be also very interesting. So sorry, I'm not giving very interesting answers here. I'm just saying this would all be great to do. And then on Michael Ehrman's question, yeah, we have financial literacy questions in there as far as I know. I think it's the standard 3 financial literacy questions, and we could. I guess we could do that in some, I don't know exactly, in some regression format where you control for financial literacy, or you look at the subsample of financial literate people.
Exactly. I mean, you just sort them like you did now, attentive, inattentive.
Yeah, exactly.
Sort them into literate.
Oh, and then exactly, yeah, that absolutely, yeah.
So I'm gonna. There's 2 more from the floor before we wrap up. And I'm actually going to restate Luca's as Luca Gemi again as another, rather than a question, as a statement, because I think the answer is yes, you could apply this to anything in the model. So fiscal announcements could be also done. Where I think his point is super interesting is, consumers are probably more attentive to tax and spending just on average than they are to the FOMC. And so you could be able to then compare the FOMC effects and the fiscal effects, and if they still give consistent answers, I think that would be pretty cool. So apologies, Luca, I've taken your question, basically answered it and put it as a suggestion. But the reason I do that is because actually Peter Rickards has a question, which just points out that the similarity of the 2 methods is quite striking, considering that their inflation expectations were going in opposite direction to what we might expect. Do you have a sense of what is allowing this? Is it that households are quite able to predict the effects on their income and also well able to link their income and consumption? Is this the income effect? Is it the income effect that's driving most of the commonality? I guess what would be nice as well, if you did it with, say, fiscal, is people might have a very different view of how fiscal and inflation and income or stuff are linked, and it would just further test the robustness of this model that worked pretty well. But I'll leave you with those 2 to answer, and then we'll wrap up.
Yeah. So let me start with the last question. We did the following exercise. When I showed you this delta CI, the consumption difference across policies, it was the sum of these different terms, the income effect, and then you had the interest rate effect, and then you have the perceived wealth effect. And you can compute them from the expectations separately. I mean, in fact, that's what we do. We compute each of these three, or I mean, we throw it all into this one equation, but you can also compute each of these three terms separately. And then you can construct the same picture. It's just on the x-axis, you don't have the model-based consumption response, but it says, for example, model-based consumption response focusing on the income effect only. Or focusing on the intertemporal substitution effect only, and so on. And we did that, and we actually found it worked best if we included all. So we had a similar prior as Luca, that this was mainly driven by income expectations, that it's just people are telling us they're very pessimistic about the income on the high interest rates. Of course, they're going to say, I consume less on the high interest rates. No, and we thought this was driving everything, but it turned out that this intertemporal substitution term also helps. In creating the strong correlation. And we were surprised by that. It was not my prior. So we don't have a simple message like it's the income effect only that is driving that correlation. I forgot the question before. The fiscal policy.
It was really just a suggestion on fiscal, yeah.
On fiscal, yeah, I think it would be great to do this with other policies. Yeah, and I think fiscal would be very, very natural. The natural next policy to do this with or for.
There's one last one, and just before we get to the end, Oleg says, shouldn't the question about literacy also be related to Julian's question? If attentive respondents are more literate, they may also be experiencing greater experimenter demand effects, which may in part explain the correlation. Because we have to wrap up, and because I know you want to defer that question, let's all, when we next see Chris Roth, let's all corner him and ask him about experimenter demand effects and how it relates to attentiveness and other things. They're good questions, but yeah, I think it's totally fair that we form co-authorship teams because of specialization of skills, and it's very clear that attentiveness to demand effects, experimenter demand effects, is going to be in Chris Roth's camp. So let me wrap up here. Also, partly because it's now after 11 my time, so I've got to go to bed. Mirko, this was fantastic. I think this is a super exciting way, particularly, bridging between what you might call a very classical, monetary policy effects via models and the sort of newer survey-based ways of trying to understand the world. And this is a lovely way to merge them. So I'm really happy that you presented it, sort of giving us an insight into it. To everybody else, thank you for your participation. And yeah, we will see you all again in about a month. So thank you for your time. And yes, we will see you next time.
Thank you, everyone.
Thanks, bye.
Yeah, thanks, Michael. Thanks, Michael.
Cheers, Mirko. Thanks a lot. That was awesome.
Okay.
Thanks.
Bye-bye.
Bye.